Hey everyone, welcome to the Naughty Samurai channel. Today we are going to talk about feature scaling, specifically standardization. By the end of this video, you will understand how to properly scale features and ensure your machine learning models perform optimally. So what is standardization? Imagine you're training a model. You have height in centimeters and income in dollars. If you feed these raw numbers into your model, guess what happens? The model freaks out and starts favoring the huge numbers, which is the income, because it's literally bigger in magnitude. It is not fair as it is biased towards the bigger numbers. That is where the feature scaling comes in, where it makes all the features play fair within the same ring. Think of it like weight class divisions in professional boxing or MMA, where you make sure the lightweight fighters doesn't go against the heavyweight ones. Besides standardization, there is another feature scaling technique known as the normalization, but we will cover that part in the next video. So now let's get into the coding part and see how to really apply the concept of standardization. As always, I will begin by simply installing all the necessary libraries that are needed, and right after that I will download the dataset directly from KaggleHub. If you have seen my previous videos, you know I always attach all the links in the description box below. So I'll be attaching the link to this dataset as well in the description box, so do check that out. After that we will import all the necessary libraries and then we will fetch the file out of the path. Finally, we will print the last 10 rows of our dataset. So this is how our dataset looks like. If we want to go into further details, we would write data.shape command and it will give us the total number of rows and the total number of columns of our dataset. So it says that in our dataset have in total 614 rows and 13 columns. Now, I have always told you that right before applying any concept in any column of your dataset, first you should check out whether if there are any null values present. If there is presence of any null values in that specific column you're working with, then the result that you will get will not be efficient and it will be highly biased. You don't want biased results. So in order to get efficient results and real results, what you need to do is you need to deal with the null values first. And I have explained in the previous videos how to actually deal with the null values. I think they are the very first videos of this series. So if you want that, you can go check that out. There I explain you different methods of dealing with the null values. Alright, before applying the concept of standardization, we have to select a column that we want to work with. I would be choosing any one of the applicant income column or the co-applicant income column because these are the columns that I've worked with in the previous videos as well. But if you want, you can choose any of the columns, but you just need to make sure that the columns that you are choosing have numerical values because the concept of standardization only works on the column with the numerical values. So for instance, you can choose the loan amount column, the loan amount term column, or any column which have numerical values, but you cannot choose the gender, married, or education column because the values are categorical and the concept of standardization can only be applied to numerical columns. Alright, as we are done with it, now as I told you before, we need to first make sure that the column we are going to work with do not have any null values. So for finding that out, we would write data.isNull.sum and we will run it. So now it tells you the number of null values present in each of the columns. So here you can see that gender column has in total 13 null values, married has 3, dependents has 15, and the column that we want to work with, which is the applicant income, has 0 in total. So we are good to go. We do not have to drop the null values, but for your convenience, if you want to work with any of the columns, I would still be explaining how to apply the concept of null values. So the technique that I would be choosing is applying the mean method. If you want, you can apply the mode method, or if you want, you can also choose to apply the backfill, the forward fill method, or replace the null values with any static number. But I would replace the null values with the value of the mean of that column. So for how can I find out the mean value of our column? In order to do so, we would write the data.describe command and I would run it, and it tells you different values for each of your columns. As we are working with the applicant income column, here are its values. The count value, it means that the total number of rows in this column are 614. The mean value which you want to work with, the mean value is 5403. So what we would do is, in order to deal with the null values, is we will replace the null values with this mean value of this column. Alright, let's apply the concept of replacing the null values with the mean value. In order to do so, we would write data, the name of our column, Fill NA means filling the null values, and we will fill the null values with the mean value of this column. And the final parameter will be the in place, which we will set to true. And it means that instead of creating a whole new data set, what it does is that it replaces in the existing data set that we are working with already. So now we will run it. Alright, so the method have been applied even though we did not have any null values present, but if there were any, what it would do is it would replace those NN values or null values with the value of mean. Now, before applying the concept of standardization, we want to take a good look at our column in a visual manner. And in order to do that, we would use the Seaborn library to plot a graph. Alright, now let's plot a distribution graph using the Seaborn library. So SNS is the short form for the Seaborn library. So SNS.displot, which means the distribution plot. And now we would write data and the name of our column, which is applicant income column. I think there are double parentheses here. We remove one. And now we write plot, that is plt.show. Okay, we run it. Alright, now we got our graph. So this is our graph, and it shows you the distribution of values in this column. So you can see the values here range from 0 to 20,000. And some even stretch up to 40,000 and 60,000 and so. Alright, so this is our this is our before view of our graph, but right after applying the concept of standardization, you would see that this graph will change drastically. Alright, now let's get into applying the concept of standardization, and then we would plot after version graph of this exact same column, and we will see what difference the concept of standardization makes it to this column. Alright, now we would import the standard scalar library, the standard scalar class from the sklearn library. So from sklearn.preprocessing, we will import standard scalar. We will run it. And now what we want to do is we want to create an object of this class. The name of the object would be SS, and now we have created an object, and the very next step is that we want to fit our data set to this. So SS.fit, within the parentheses there will be data, and we would write double parentheses here because this is how it works, and between them will be the name of the column. Oops, okay, applicant income. Now we can run it. Alright, now the object has been created and it has been fitted to the dataset. Now the next thing that we would do is we would transform our dataset. So what this fit method does is that it actually processes the dataset. It does not change the dataset yet, but after we apply the transform method, it will finally change the overall dataset, and it will apply the concept of standardization after learning about the dataset using the fit method. Alright, now we would write ss.transform, and we can just copy paste the same thing with double parentheses. Alright, we copy this and paste it over here. Now we run it. Alright, now we can see that the values that were previously there have now all been scaled up. You can see previously that the values were kind of in range. They range from around 12,000 to 2,400, 3,400. They were all in integer numbers. But now after applying the standard scalar concept, you can see now these values have been stretched and some values are even in exponential nature. Alright, so this is how we apply the concept of standardization. Now what we want to do is we wanna kind of concatenate this column with the standardized values into our existing data set. How will we do that? Alright, let's do this. We create a new cell. The column name that we want can be anything. I would name it applicant income 2. Okay. Alright, now name of the new column would be applicant income 2. Next would be pd.dataframe. PD means pandas library. pd.dataframe, and within the parentheses would be, you just copy paste. Let me go up. Okay, we would copy this line and paste it within the parentheses here. And another thing that we need to add is we would write columns, and within the parentheses we would write X, and we can run it now. Alright, it ran. Now let's print the dataset again. So this was our previous column, and now you can see after running this, you can see a new column has been created with the name applicant income 2, and now you can see the change in the values. Before it was 5849, and now it has been changed to 0.072991. In the same manner, all of these values have been scaled up into this. Not only that, the value of mean and standard deviation also changes here to 0 and 1. How this concept of standardization works, you won't understand it unless I show you it in details using the formula. So let's go. Alright, so this is the formula for finding out the value of scale values, which is z equals to x minus mu divided by sigma. Here x stands as the original value, mu stands for mean, and sigma stands for standard deviation. So the moment you apply this concept of standardization, what it does is that for all the features you apply this concept to, it changes its value of mean and standard deviation to 0, and it changes the standard deviation to 1. And this thing doesn't only apply to one feature. As we have applied this concept of standardization to this applicant income column, the value of its mean and standard deviation in the new column changed to 0 and 1. I will show it to you, but let me first explain you the concept. You can by applying this technique, you can change the mean and standard deviation and bring them to a constant value for all the columns. So now, as we applied this concept to this column, the values of mean and standard deviation for this column change to 0 and 1. You can do the exact same thing for this column as well, this column over here. And what you can do is, by applying this formula, you can change all of these features. Like this is a feature, this is a feature, this is feature 1, 2, 3, 4, and all of this individually are features. You can, by applying this concept, you can change all of these features with the new value of mean and standard deviation to be 0 and 1. So now what you can notice that right after we apply this concept, all of the features are now constant value of 0 and 1. It's very beneficial to it's very beneficial to work with our dataset, as all of this dataset have now constant mean and constant standard deviation. So it actually garners better results. Alright, now we will check out the value of mean for this new column that we created over here. Let me write data.describe again, and let's run it. Now you can see that the values of mean and standard deviation for the new column have been changed. The value of mean for this column is minus 4.333, which equates to 0. It's to the power minus 18, so it actually equates to 0. And the value of standard deviation is 1. Now we would like to take a good visual look at our graphs before and after scaling. So I feel a bit lazy, so instead of typing it out, I just copy paste it. I suggest you write it down, so you will understand the concepts a bit better. Okay, let's run it. Instead of the distribution plot, I'm using the histogram plot because it kind of garners the image side by side. Alright, let me run it. And now you can see the clear differences before scaling and after scaling. Before scaling, the values stretched up until 40,000, 50,000, even 80,000 in some cases. But now you can see right after scaling, the values are now all stretched between 0 and 6. In most cases, I mean, very few values are after this value 6. I think only 2 or 3. But now you can see that the concept of scalarization actually scales down all the values, so it actually fits into our model well, and our model can work on the data better. So this is it for today, guys. We have successfully applied the concept of standardization. I would be talking about normalization, which is another technique for feature scaling, in the very next video. So this is it, guys. I really hope you liked the video and understood the concepts well enough to hit the like and the subscribe button. Until the next video, keep your mind sharp, your code clean, and stay sane. The Naughty Samurai signing off.